Hello everyone, I'm Shudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I'm going to talk about a topic of electrical circuit and network. So this subject is designed for second year Diploma Electrical Engineering students. And this is the lesson plan of this subject. Lesson plan Unit 2, Unit 3 and Unit 4 is I will talk, and this is in Unit 2. So in Unit 2, we have the study of J operators, then concept of complex inductance rectangular and polar form, complex impedance in rectangular and polar form, then series AC, RL, RC, RLC circuit, impedance, reactance. So this part is already covered in the previous lectures, and my today's topic of discussion is the phasor diagram and the impedance triangle of RL circuit. So this is the today's topic of discussion. So here it is phasor diagram and impedance triangle of series RL circuit. Phasor diagram, impedance triangle. This two is very important. And RL circuit, we already talked about RL circuit. I think if you have gone through my previous lectures, so it's not so tough to understand that what is RL circuit. So RL circuit is basically a circuit where a resistance and a inductance will be there in the circuit. So in case of RL circuit, there is a voltage V equals to Vm sin omega t. This is the supply voltage. The total voltage of the circuit is V, and we have few things we need to remember, that the current flowing here is I0 current. This is the resistance, symbol of the resistance. This is the symbol of the inductance. So the resistance is R and L is the inductance. So the voltage across the resistor or the resistance is VR. The voltage across the inductor is VL. The total voltage is V. So VR voltage across the resistor R. This is VR. VL is the voltage across the inductor L. And V is the total voltage of the circuit. Now, this part we already completed in the previous lectures. So in this lecture, we'll try to understand about the phasor diagram of the RL series circuit. So here I explain the steps to draw the phasor diagram of RL series circuit. So it is divided into 4 parts. In part 1, look, current I is taken as reference. So current I, where is current I? This is current I taken as reference. That means along, this is x-axis. So which one is x-axis? Let me show you. This is the x-axis, and this is the y-axis. So along x-axis we consider current. Fine. We take current as our reference phase. Now the voltage drop across the resistance VR, that is equals to IR, is drawn in the phase with the current I. Look, we know that for a purely resistive circuit, the voltage and current always lie in the same phase. So here, the voltage across the resistor is VR. So the voltage across the resistor VR, that is equals to IR. Why? And these both are in the same phase, that is along x-axis, because we know that for purely for the resistance, the voltage and current always lie in the same phase. There is no phase angle for a resistive circuit. So first part we considering it's a resistive circuit, and the voltage drop across the resistor VR equals to IR is drawn in the phase with the current I. So this part is completed. This is the part VR. This is VR, and we consider that the current I is IR. No problem with this. Next, the voltage drop across the inductive reactance VL equals to IXL. I talked about 3-4 times in the previous lecture that why the inductive reactance is VL or VL equals to IXL. So IXL is the inductive reactance. This is the voltage drop of the across the inductor, and that voltage drop across the inductor is called inductive reactance. Inductive reactance. So this VL equals to IXL is drawn ahead the current I. Why it is drawn ahead the current I? Why this line is so important? Drawn ahead current I. Because we know that for a inductive circuit, the current lags voltage by an angle 90 degree. The current lags voltage by an angle 90 degree. So this is the inductor. So current phasor along x-axis. So we have to draw VL equals to XL ahead of current I. So ahead of current I. Please try to understand. Ahead of current I. So ahead means the VL is ahead, means this is in anti-clockwise direction, or you can say the current I is in the clockwise direction of VL. So if the situation is like this, then you can say that the current lags voltage by an angle 90 degree. So here it is lagging the voltage by an angle 90 degree. So this current is lagging the voltage VL by an angle. This is the 90 degree. I think now it is clear to all of you in the pure inductive circuit. Now, no confusion up to this part. So in the next part, try to understand the vector sum of two voltages drop VR and VL is equal to the applied voltage V. So this is one voltage drop VR across the resistance. This is another voltage drop. So this one is one voltage drop. This one is another voltage drop. Now, so what will be V? The vector sum of these two voltage drops VR and VL is equal to the applied voltage. This is the applied voltage V. Fine. So in this way, we can find the value of the total voltage of the circuit. So this is the phasor diagram. In this way, we have to draw the phasor diagram of the RL circuit. Now, if you consider this, this is the current phasor, this is the VL phasor. So current is lagging behind voltage at an angle 90 degree. So for inductive circuit, this is the property of the inductive circuit. Current is always lag behind the voltage, or you can say in the different way that voltage, the inductive voltage is leading at an angle 90 degree from the current. Now just draw this part, and then with the vector triangular formula we can easily find that the summation of VR and VL is equals to the applied voltage V. Next, in right angle triangle OAB. Which one is right angle triangle OAB? This is right angle triangle OAB. This is one OAB. OAB. So this is the right angle triangle OAB. So here in this circuit, VR equals to IR because both are in the same phase. VR, IR, both are in the same phase. VL equals to IXL. Look, VL equals to, what can we say? VL equals to IXL. Because we already know that the inductive reactance VL equals to IXL. No problem with this. So what is the problem? And we know that XL equals to 2 pi FL okay. So here omega equals to 2 pi F. So actually XL equals to omega L, and here already this value is given, or put the value of omega. So from the previous diagram we can easily define, or using this triangle OAB triangle we can say that V equals to VR square plus VL square. V equals to VR square plus VL square. V equals to VR square plus VL square. So as per the Pythagoras you can say that V square equals to VR square plus VL square. So V equals to root over VR square plus VL square. Now what is VR? VR equals to IR whole square. And what is VL? VL equals to I into XL. So put this value. So what is V? V equals to I into root over R square plus XL square. V equals to R square plus XL square. Or you can say that where I, what is I? I is the L, that is equals to V by Z. Okay. And where Z equals to root over R square plus XL square. Because we know that Z equals to V into I. So this is actually the V. So V is actually I into Z, and this is the value of Z. So what is Z? Z is actually root over R square plus XL square. So in this way we can find the value of the impedance of the phasor diagram. Now phase angle, how can we find the phase angle? In RL series circuit, the current lags. I already told you what happened for the current. Currents always lags the voltage by 90 degree. angle known as the phase angle. It is given by the equation tan phi equals to VL by VR. Why it is VL by VR? Look here, VL by VR, height by base, tan phi equals to height by base. So that is equals to VL by VR. We know that VL equals to IXL, VR equals to IR. So I cancel XL by R, or you can say that phi equals to tan inverse XL by R. So in this way we can find the phase angle also. Now for this impedance triangle, or you can say the impedance triangle of RL series circuit. What is impedance triangle? Impedance triangle is nothing but the phasor diagram or voltage triangle, all the same. How it is same? Let me explain that how it is same. So we know that for inductive circuit, the inductive reactance XL always lead from the current. So if you can remember this diagram, so here VL was leading from I. So this is VR, this is VL, this is VR, this is VL, and this is VZ. Now we can easily convert this voltage triangle to the impedance triangle, because V equals to I into Z. Z is the impedance of the circuit. Now for this case, VR equals to, what is the value of VR? It is nothing but I into R. And what is VL? VL is nothing but I into XL. Several times we have done this. Now, so here V equals to I into Z. So now just remove all these V, I, V and I, also this I. So what you will find from this same voltage phasor diagram, this phasor is R phasor, this phasor is XL phasor, this one is Z phasor. So is it difficult? I think no, it's very easy. So what I have to do, I need to write all the equation of V. So this V equals to IZ, this VR equals to IR, this VL equals to IXL, then just remove all the I. So you will find R, XL, Z. So Z equals to root over R square plus XL square. So this is the impedance triangle. This is very easy, I think so. What you people are thinking, just share with me after this lecture. Look here also the same thing. This is R, this is XL, this is Z. I already defined how to do this because this was VR. We know that VR equals to I into R. XL means this was VL, that was I into XL. That means this was V, supply voltage. So I into Z. I into Z. So this diagram we draw at the time of phasor diagram. This diagram we draw at the time of phasor diagram. Can you remember this? Yes, obviously you can remember because you all are very much intelligent. So here what we have to do, just remove this VL and this part. After removing, what we get, this is Z axis, this is XL, this is R phasor. So that is actually the impedance triangle of RL series circuit. So this is the lecture for today's class, because in today's class we have chosen only very simple or few steps, that is phasor diagram of impedance triangle, phasor diagram and impedance triangle of series RL circuit. But talk something about the power also, because these all are related topics. So power, in just let me 5 to 6 minutes I will finish the lecture. Power in RL circuit, series circuit. So very easily you can understand that in a alternating voltage applied across the current is given. What is the current voltage equation for AC supply? V equals to Vm sin omega t. Yes, and the equation of current I equals to Im sin omega t minus phi for RL circuit. The current is lagging at an angle phi. For that reason omega t minus phi is coming, and here equals to Vm sin omega t and I equals to Im sin omega t minus phi. Equation number 1, equation number 2. Then the instantaneous power is given by the equation. What is the instantaneous power? You all know this. That P equals to Vi. This is the instantaneous power. Now, here, putting the value of V and I from the equation 1 and 2 in equation 3. So, P equals to Vi equation, we have to put the value of V and I in 3. We have to put the value V and I in equation 3. Then we'll find Vm sin omega t into Im sin omega t minus phi. Then Vm Im by 2. So what is sine omega t into sine omega t minus phi? That is equals to 2 sine omega t minus phi. So this 2 is extra we are taking, so we have to divide by 2. So Vm Im by root 2. We can break 2 in this way. 2 equals to root 2 into root 2. So this way we just break these two, Vm by root 2, Im by root 2. So 2 sine omega t minus phi sine omega t. We just take a 2 here. Yes. So 2 sine omega t minus phi means cos phi minus cos 2 omega t minus phi. And then multiply Vm Im by root 2 cos phi, then Vm Im by root 2 cos 2 omega t minus phi. Next, P equals to average of Vm by root 2 into root 2 minus average of Vm Im by root 2 into root 2 2 omega t minus phi. This will be I. That is equals to Vm Im by root 2 into root 2 cos phi minus 0. So this part will be equals to 0. Then we can say that P equals to V RMS, because Vm by root 2 V RMS, Im by root 2 I RMS. Here it will be Im, this will be Im. So cos phi, that is equals to Vm cos phi. Now, where cos is called the power factor of the circuit, so cos phi equals to VR by V. And what is VR and what is V? VR is the voltage across the resistor, and V is the applied voltage. So VR is IR and V is IZ. So if we vanish II, we will get R by Z. That is the cos phi, or the power factor. The power factor is defined as the ratio of the resistance to the impedance of an AC circuit. Resistance to the impedance of a circuit called the power factor. And so when we learn that what is active power, reactive power, then this definition will obviously change, and I will discuss that on the later classes, later lectures. So putting the value of V and cos phi from the equation 4, the value of power will be, so with the help of this equation, we can easily find the value of power, that is P equals to Iz into I into R by Z. That is I square R. ZZ will vanish. So how it is happening? I have to understand this also. P equals to Iz. P equals to Iz into I R by Z. So this ZZ will vanish. So I square R. So this is the power loss equation. So from equation 5, it can be concluded that the inductor does not consume any power in the circuit. So inductor is actually not consuming any power from the circuit. So who is consuming the power? R is actually consuming the power from the circuit. Now, try to understand this one. This is the power, current, and voltage waveform of the circuit. So this is the voltage waveform. Look, this is the voltage waveform. Red color is the current waveform, and this one is the power waveform. Now, the voltage, we know that V equals to Vm sin omega t, so it is starting from 0, then pi, then 2 pi. This way it's completing its waveform, and we know that current is lagging at an angle phi. So if we consider this is phi, so phi, so current is starting lagging at an angle phi, the phi angle. So current waveform is this one. Current, in this way the current is coming. It is actually lagging at an angle phi. Okay, and the power. The last part is the power triangle. So from where the power triangle is starting? The power triangle is starting from this point. Yes, from here the power, this one is the power triangle. Now, the various points on the power curve are obtained by the product of the voltage and current, because we know that P equals to V into I. If we analyze the curve carefully, it is seen that the power is negative between angle 0 and phi. Look, this area power is negative. This particular area the power is negative. This power is negative power. Yes, angle between angle 0 and phi the power is negative, and between 180 degree and 180 plus phi, and between 180 degree and 180 plus phi. So in this area 180 plus phi, this area during the rest of the cycle of the power is positive. So this area the power is positive. Here also the power is positive. The current lacks the voltage, and thus they're not in the phase with each other. Current is lagging actually from the voltage. They are not in the same phase with each other. The current is lagging behind the voltage. In this way, we can understand the power, voltage, and current waveform. So to make this PPT, I basically take help from this particular website, and I go through a few books. You can follow all these books for the better understanding of these RL circuit, phasor diagram, and impedance triangle, or you can say the voltage triangle. For any doubt, you can contact with me anytime. If you have any suggestion, need any suggestion or any type of topic related information, you can contact with me anytime. So thank you all for watching this video. God bless you.